Start.
Yeah, Steve, why don't you go ahead and start? Nick's going to do a restart. He'll join us again. Um, want to welcome those of you who are watching this to our winter weather webinar. We'll have joining us today Steve Templeton, the chief meteorologist from KMOV, the CBS affiliate in St. Louis. And joining us in a bit will be Nick Stewart. He is a meteorology student at Western Illinois University. Those of us who are joining us live right now, please mute your microphones. We'll have a chance for question and answer at the end. And Steve, let's go ahead and turn it over to you. What have you got for us today?
Thank you. I'm going to screen share here. And can you just confirm that you're seeing my screen? Do you see that? Okay. It looks like it muted you. So, but I hear, yeah.
Yeah, I muted myself. Yep.
Oh, okay.
So, all right, let's do this.
All right. So what I was told is we want to talk about winter forecasting, snow, ice, and why is it so difficult? What are the challenges? So I thought I'd start off with a little bit of humor. This one says in the upper left of the cartoon, just a minute, he's watching his favorite comedy as he looks at the 5-day forecast. And if he thinks the 5-day forecast is comedy, then he'll love our 7-day forecast. There are some out there trying to do 30-day forecasts, not local TV people, but because we know better. Why is forecasting so difficult? Here's another one. So that's our best guess as usual. I wouldn't bet the rent on it. I'd never say that on air, but I am pretty honest on air, and I'll let people know when I'm not real confident about a forecast. Even today, I told them the cloudy skies in St. Louis, it was a tricky forecast. They may hang around longer than we expect. And this is pretty much what everyone thinks we do. Just throwing darts. It's all in the wrist. It's actually a lot more technical than that, and I think you'll understand after we talk a little bit more about forecasting. All right, so here's just kind of the short answer. Why is snow forecasting so difficult? Snow and ice forecasts are much, much more specific than rain, temperatures, wind, clouds, or pressure forecasts. The margin for error is thin, because slight errors create a big change in the impact. A minute error in a snow forecast could mean the difference between people saying, what snow, or saying, oh, we got 5 inches of snow. So the margin of error is pretty tight. Okay, obviously I went a little crazy with the cartoons, but I'm trying to have fun with this. So this one is Garfield. It says, taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. And Garfield says, this guy's never wrong. Well, that's my kind of margin of error. And you'll notice that some of the forecasts, or actually not just forecasts, but the actual snow that fell in some areas, I'll cite some examples, have crazy, crazy ranges. Here's a recent one that hit Chicago. So you're going to see the ones, hopefully you can see my cursor here, in the city. This is lake effect enhanced or de-enhanced near the city, actually. But you have 1 inch of snow in the city, and up in the suburbs you have 15 inches, 12 inches, 11 inches. So technically 1 to 15 inches was an accurate forecast. Now, I don't think Tom Skilling at WGN was going on air and saying 1 to 15 inches. I know they were saying much less snow near the lake, but bottom line is snow forecasting is so difficult because the margin of error is so thin. Somewhere in between this 8 inches and 1 inches, someone was expecting not a lot of snow and got a lot of snow. And that happens. All right, so it's more specific of a forecast than rainfall. Instead of probability, you know, when we forecast rain, we say, hey, 30% chance of rain. And most people are like, okay. We're a little more specific. I like to be, you know, what type of rain? Is it going to be a downpour? Is it going to be long lasting? What's the timing? But still, 30% chance of rain, usually people are satisfied with that. If I told you a 30% chance of snow, you would not be satisfied. You want a specific pinpoint forecast, and I don't blame you. So it's more like 2 to 3 inches. The bigger impact, too, is on snowfall. If we miss on rain, you're not going to notice. If I tell you I'm forecasting 0.31 inches of rain, and we actually get 0.6, you probably don't even know the difference. You just know it rained, and you think, hey, weather guy nailed it. We got rain. But if I say 0.3 inches of rainfall or snowfall, which would be equivalent of about 3 inches of snow, and we end up with 6 inches of snow, you're going to say, oh my gosh, they get paid for being wrong all the time. They forecasted 3 inches. We got double that. And I don't blame you. The impact is big, and it's because the margin of error is so small, and our errors are much more visible. When we mess up a forecast in the winter, you see it. You see it on the ground. And if it's cold for days and days and days, I see my error on the ground for days and days and days. Okay, so for snowfall forecasts, all of these need to be right. We need to get the track of the low, the location of the rain, snow, ice line, which is really important around St. Louis. We get that a lot, where you get rain, then it changes to snow, and then maybe it goes back to rain, then changes to all snow. That really impacts how much accumulation you're going to get. This is the biggie, though, this liquid to snow ratio. I call it the multiplier effect, although really all it does is multiply my errors, and I'll explain that coming up. But you got to get that right. Temperatures on the ground and aloft. Obviously, you got to get temperatures on the ground right. It's not going to accumulate, the snow won't, if the temperatures aren't below freezing. But what's really important, too, and Nick's going to talk a lot about this, is temperatures above. And those are hard because we don't have a guy with a thermometer at 3,000 feet in the air. And then we're taking that, putting it into a forecast model and predicting / assuming what the temperature is going to be at 3,000 feet. If the temperature at 3,000 feet is above freezing, instead of snow, you might get sleet, freezing rain, or just rain. It really can mess with your forecast. And, of course, you also have to choose the correct computer model. There's a bunch of different forecast models, and we tend to use a blend of them. Even then, things can go wrong. Here's an example. Snow banding, this is one of those things that can go wrong, and that's where you get this thin band. It's almost like think of like a squall line of storms, but instead of thunderstorms, it's like a little thin line of heavy snow. So this produced 8 to 10 inches in this heavy band area. No banding down here produced only about 1 inch. So again, in the Chicago area, 1 to 10 inch forecast would have been right, predicting exactly where that thin, and by thin I would guess that's probably a 30-mile band, 30-mile wide. It's very long, but it's 30 miles wide. Predicting exactly where that's going to set up is really a big challenge. All right, here's an example of track of the low. This is actually from what we consider the snowfall of record, at least in this generation in St. Louis. It's the blizzard of 1982. And each one of these lows represents a position in time. So here it was on January 30th. Here it was the night of January 30th. Here it is in the morning of the 31st. And here it is on the night of the 31st. So that's the kind of path it took. The heaviest snow is always just to the north of the low, and this is indicating where that heavy snow was. So subtle shifts in this track make a big impact. Again, margin of error is really, really thin. So here's an example of how much snow fell. This is that blizzard of 82. There's 25 inches in a county in Illinois. This would be in my viewing area, and there's 4 inches. So technically, if I had forecasted 4 to 25, I would have been right. I probably would have been tarred and feathered and run out of town, but technically 4 to 25 would have been good. You know, it's just not useful. You can't. How do you plan? How does the public plan when you say 4 to 25? And I can't tell you where the 4 is or where the 25 is until it's on the ground. It's just not helpful, and it's why snow forecasts can make us look so bad. Here's another one. This is in the St. Louis metro. They had 10 inches up in St. Charles, and this is in South County. So this is a highly populated metro area. And South County had that pinkish color right here is 21 to 24 inches. So that's a 14-inch, a more than 1 foot snow difference over 23 miles. That's a big difference in a small area. Margin of error, again, really, really thin. And you can look really good if you forecasted heavy snow to these people, and you can look like an idiot to these people. And that's, in essence, what TV meteorology in general does, is it cuts you down at the knees, humbles you, and makes you look really bad at times. Okay, so the track of the low. What if we were to shift? So what if I took this low and just each one of these purple lows, let's say this is where it actually went. So that's about 80 miles to the northwest of the path of the actual low. What does that do to where the heavy snow is? This is what it does. So if you shift the track of the low 80 miles, or let's say you missed it by 80 miles, you thought it was on this path and it actually took the path about 80 miles to the north, this is what you end up with. So had you been forecasting, I think a realistic good forecast for this blizzard of 82 probably would have been something on the order of 12 to 24 inches, just a wide, you know, because once you get over 12, I think people are planning for 12 as much as they would plan for 18. It's the same at the end of the day. But if you had said 12 to 24 inches, and St. Louis, parts of it, the heaviest was down here in South County, now gets less than 6, you're in trouble. Because you've got people that have bought generators, you've got businesses that have shut down, and they are all calling you and calling you names while they're calling you and emailing you and tweeting at you. And but that getting the track of those is just one of those things that you need to get right. The rain-snow line, another biggie. So this is an example of, this is really kind of a classic setup where the cold air is to the north where it's all snow, the warmer air is to the south where it's all rain, and here's this zone of rain, snow, ice. Could be sleet, could be freezing rain, and a lot of that depends on the temperatures aloft, and that is so hard to pinpoint. So what is the rain-snow line? That's where warm air aloft melts snow. Snow will fall to the ground, but if it hits a even 300-foot thick area, as it falls through that 300 feet of above freezing air, it melts. And it could freeze once it hits the ground. It could come to the ground as all rain if you're sitting at 32 degrees. So forecasting a 300-foot thick area above my head where I don't have thermometers, I have assumptions on what the temperature is up there, is very difficult. The margin of error, again, is really thin. So that's another thing you have to get right, the rain and snow line. Here's the Groundhog Day storm. This one made me look like a complete idiot. The forecast was high impact, 12 to 24 inches. The city shuts down in anticipation. So I don't know, since this is the Illinois Broadcast Association, there may be some people from Chicago. 12 to 24 might not shut the whole city down, but some businesses would shut down. In St. Louis, it shuts the whole city down. And this is actually an example of the Weather Service forecast, just to show that I wasn't the only one who was forecasting this. But this would be St. Louis here, just inside the 12 to 24, and just outside less than 12 inches. So technically, the forecast is 1 to 12. Because we're just so unsure. And we express that uncertainty, but when you tell people, look, this is a tricky forecast, it's very uncertain, but some spots are going to get up to 24 inches, all they hear is 24. And so, rightfully so, though, the city kind of shut down. People bought generators. I heard from one guy who bought a generator and was very upset. Here is the actual forecast. Notice all this blue. If you look at the legend, that's 10 to 20. Dark blue is 20 to 30. So very close to St. Louis. I'm going to put my cursor right over St. Louis. We missed it. We missed it by a little, not a lot. I drove to Warrenton, which I think is maybe 40 miles outside of St. Louis, and they had 12 to 15 inches of snow. And so we did some live shots out there to show people in the city, hey, it did snow. It was just mist. But this St. Louis area got 3 inches of sleet, and that was because of warm air aloft. It converted what would have been about 18 inches of snow to 3 inches of sleet. Now, 3 inches of sleet is, that's pretty significant. But when you've been forecasting 12 to 24 inches, and this could rival the blizzard of '82, and it doesn't happen, people are rightfully upset. And again, it goes to show that if I had missed on a rain forecast or severe thunderstorm forecast, people probably would have gone about their day saying, oh, thankfully it didn't storm real bad. They missed it. But when you miss a snow forecast and the city has shut down, that's a much bigger impact. Okay, the multiplier effect, multiplying my errors. So this is interesting. This is actually how we forecast snow. We forecast rain first. So in order to forecast a big snow event, I first have to figure out how much liquid I think is going to fall from the sky, and then I convert it. A typical ratio is 1 inch of liquid rain would be 10 inches of snow. So if I have, let's say, 0.5 inches is what my forecast is of liquid, that would be 5 inches of snow. So it can vary, though, this ratio. Really dry, fluffy snow is a low ratio. It can be like 7 or 8. And then when it's really wet, when it's really wet, it's a low ratio. That can be 7 or 8. When it's really dry and fluffy, that's when it's really high. And it can be 15, 18, even 20. 20 is a little on the extreme, but we do get that around here. And that's where, if you are forecasting 0.5 inches of liquid and you think it's going to be really cold, let's say the temperature is 12 degrees, and you're going to get 0.5 liquid, you're going to have to multiply that by 20 So instead of multiplying by 10 and getting 5 inches, now you're looking at 10 inches of very fluffy and dry snow. So that multiplier effect is really important. It's one more thing you have to get right, because if you don't, you bust. Okay, here's an example. Let's say my forecast is 0.2 to 0.3 liquid. Multiplied by 10, you get 2 to 3 inches of snow. Okay. Well, let's say the actual was 0.5. So I was only off by about 0.2. Again, margin of error is going to be really thin here. But also my multiplier was 13 and not 10. So I was off a little bit there. Actual snowfall, 6.5. So the public says, whoa, 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 what happened to the 2 inches of snow? And we got 6.5. And they're right. It's just extremely difficult to pin down all of these variables that have such a thin margin of error. And it's almost amazing when we do it and do it well, and the public's like, oh, they got it right, and they assumed we're supposed to get it right. Whereas most meteorologists are like, oh my God, I can't believe we got it right. But that margin of error, pardon me, is very thin, and the multiplier effect makes it even thinner. All right, final thoughts for anyone old enough to remember Jerry Springer. Sneaky and subtle impacts. Okay, the DOT, Department of Transportation, doesn't treat if not warned to it. So when sometimes you have freezing fog, freezing drizzle, these are very subtle, not big type of storms, hard to really pin down and predict the local effects. Maybe you're only getting a ½ inch of snow and it comes right before the commute, but you weren't expecting a ½ inch. You were expecting flurries to nothing, and the DOT decided not to treat. A ½ inch on untreated cold ground right before the commute is disaster. And I know it because I've seen it here in St. Louis. I mean, it would be hundreds of car accidents. 1 inch of snow when you expected flurries, big difference. Now, if you expect 1 to 2 inches and the DOT treats, the impact is low. So part of what we're doing is not just forecasting what's going to fall out of the sky, but also what are the impacts? Are the roads treated well? Is it a Saturday morning or where there's not a lot of traffic, or is it a Monday morning when there's going to be a lot of traffic? These are things that we have to take into consideration when we try and predict what the impact is of the storm. Then you've got radio DJs, attention seekers on social media, and water cooler talk that can all shape public perception. The radio DJ thing drives me nuts because I hear it all the time, and you'll hear radio DJs say, it's going to snow today. Maybe it will. Maybe it won't. They're saying 5 to 10 inches. And I'm going, what? My forecast is like 2 to 4 inches. Where did they get 5 to 10? And now everybody's going to buy bread and milk and freak out. Well, when they don't get the 5 to 10, they don't blame the radio DJ. They say, you guys, meaning the meteorologists. So we get lumped in with forecasts that are not our own forecasts, including people on social media who like to hype storms, because if they can scare you, they'll get you to click on their site. It's very perverse, and it's something that in our world of meteorology we know is happening, and it's hard to thwart. But I think in the end, over time, people are going to realize that going to trusted sources for your forecast is going to be the key. And as long as we're not hyping and being honest with people, especially when we make mistakes and communicate uncertainty, then I think they'll realize that we are honest and we are a trusted source. And I think Nick is going to talk a little bit more about that as well. And I am going to, I think, end my screen share.
Yeah. All right. Is anyone has questions for Steve before we turn it over to Nick?
Can you hear me, by the way?
I can hear you guys.
Awesome. Okay.
All right, Nick, the floor is yours.
Yes. Sure. To answer your original question, when we first started opening, by the way, yes, finals are over with. They're all done with. So officially a degree meteorologist as of yesterday at like 8 o'clock at night. So
congratulations.
Good feeling. All right. So first we'll kind of touch on some of the forecast for winter weather. So he talked a lot about many of the different factors that go into it, and one that I'm going to touch on real briefly here is the temperature forecast for the atmosphere. So we'll start sharing that real quick. So this is a very common graphic. I assume you can see it right now. It's a very common graphic shown by the National Weather Service, which basically shows the 4 different types of precipitation we can see with these winter type of setups. You have the rain events, you have freezing rain, sleet, and snow, and all these are very dependent on the type of temperature profile of the atmosphere, because as you might know, as a lot of you learned in Weather 101 if you took that in college or something, is that the environment or the atmosphere is not the same temperature all the way up. Typically speaking, it gets colder the higher up you go, but with winter weather forecasting, that gets really complicated because that's not always the case. We have things such as temperature inversions above the surface, which really complicate forecasts. So ideally speaking, if the entire atmosphere above you is all above freezing, you're going to be dealing with rain. If the surface of the ground, so if your ground level is below freezing, but above and aloft is above freezing, you're going to have basically a supercooling that's going to happen. So rain is going to fall, melt in the upper atmosphere, but as soon as it hits the surface where it's below freezing, it's going to freeze on impact. When you have sleet, it's basically you have frozen precipitation that melts in a warmer area of air above the atmosphere and then refreezes as it falls its way to the ground. So refreezes before it hits the ground. And then finally for snowfall, it's typically of a completely frozen atmosphere above the surface. So that's another complication for winter weather, is you have not only you're dealing with all these different tracks of the storms, you're also dealing with a very intense temperature profile of the atmosphere you have to worry about. And so, real quick, this is something that is definitely a little bit more complicated to look at, but it's called the skew T. It's something that we use for forecasting. And while weather models show a very, surface, so basically a large geographic area, so such as like a snowfall map that he was showing before, you can see snowfall accumulation across a very large area. The skew T that you're looking at here is a point selection, so it's at one specific point on the surface. It shows basically a profile of the atmosphere. So what you're looking at here is the red line is your temperature line, and your green line is your dew point line, which is a good indicator for moisture in the environment. So that's like a real basic skew T that you're looking at here. This is really what you're going to be looking at. It's the red line and then the green line. And then the temperatures, they call it a skew T because when you're looking at this, the temperatures, they're, should we say, skewed. So if you look at the very bottom middle there, I don't know if you can see my mouse or not, but it's a 0 degrees. So we're looking at Celsius. So that is your freezing line, this blue line that basically skews across the screen. And that's what we're looking at when it comes to forecasting for winter weather events. So here we have 2 basic skew Ts for what we're looking at. So again, when we're talking about sleet, you're below freezing, then a little bit above the surface, but not very close to the surface. It tilts above freezing, and then it goes back below freezing before the surface. So basically the hydrometeors that are falling from the sky, they are frozen, they melt, and then they refreeze, and that's your sleet. As opposed to when you're looking at an all-snow event, your entire atmosphere is below freezing, and that's all snow. So those are the events that are really easy to forecast, generally speaking, as when you're looking at a very simple temperature profile. And then freezing rain is when things get really complicated, and freezing rain is definitely one of the most difficult things to forecast for, I think. And it's definitely one of the most important things to forecast for, because freezing rain can cause millions, if not billions of dollars of damages with these really significant events. Basically, the freezing rain will cool on power lines, cool on trees, and you start dealing with massive power outages. And this freezing rain in general is just a huge thing I hate forecasting for. And we haven't really had a real significant ice storm that I can remember, at least in my area, like northern Illinois, in quite a few years. I think the last one was like 2008 or 9. So we've been pretty lucky with freezing rain events. But this is what you're looking at for freezing rain, where it's a cold environment, it's warm above the surface, but right at the surface, it dips below freezing again. So basically, any raindrops that have melted in the upper atmosphere hit the surface, super cool, and basically freeze on contact. And then you start having just accumulating ice events. So in addition to not only the temperature profiles you're looking at, you're also going to be looking at things such as the moisture content in the atmosphere. So if you're looking at a dry area of the atmosphere, basically above you, that'll basically evaporate a lot of the snowfall or rainfall that is falling. So you get a lot of things like dry slots, where it looks like it's snowing on radar, but in actuality, it's all melting or evaporating before it hits the ground. So just yet another complication when it comes to winter weather forecasting. And as you can see, combined with both mine and Steve's presentation so far, you can see why winter weather forecasts generally can be all over the place and be very complicated. So next I'm going to kind of touch on the different types of watches, warnings, and advisories you'll see, because a lot of times, not only is the public very confused on a lot of these different types of things, but I think a lot of times people in the media, they don't entirely understand a lot of these things either. So the watches, warnings, and advisories that we get from the National Weather Service, they all originate from your local National Weather Service office. So the big U.S. map on the left there, that is all of the forecast offices in the lower 48. So you can see there's a lot of them. In Illinois, we actually have 5 that cover different parts of the state. There's a lot of offices that cover, and that's why a lot of times you'll see some forecasts differ from office to office, although I've noticed in the last few years that communication between these different offices has been absolutely phenomenal, and you'll see a lot more streamlined forecasts. So you don't see huge different forecast variations on what we call them the county warning area borders. So you look at the right map there. Again, that's your different offices for the state of Illinois. So we have Davenport and the Quad Cities for the northwest portion of the state. You have KLOT, or the Chicago office, which is actually in Romeoville, Illinois, which covers through the northeast portion of the state. ILX, or Lincoln, Illinois, that's your central Illinois office, which covers much of central Illinois. And then you have St. Louis, and then Paducah, Kentucky. So you can see all these different areas all are issuing different warnings and advisories for your state. In addition, these different county warning areas have different criteria for your warnings, which also complicates matters for the public when you see, one place is issuing, a severe, a winter weather or a winter storm warning for such amount of snowfall, but elsewhere it's only a winter weather advisory. So for winter weather advisory, we're pretty much, Illinois is divided in 2 different halves. You have the northern half and then the southern half of Illinois. And the Paducah, Kentucky is the exception in this case. So in Illinois, if you're in the blue portion of the state, Chicago, Davenport, or the Quad Cities area, Peoria, Champaign, it requires 3 to 5 inches of snow in 12 hours. That if you're looking exclusively at snowfall forecast for winter weather advisory. Winter weather advisories can also be prompted by freezing rain and that kind of thing as well, or even just blowing snow can be issued a winter weather advisory. But in regard to snow, 3 to 5 inches of snow in 12 hours for northern Illinois. And then for southern Illinois, any amount less than 4 inches of snow in 12 hours will warrant a winter weather advisory. And basically these are issued when hazardous weather or winter weather is either occurring, imminent, or is very likely in the short term, or even like the nearest term. So winter storm watches, these are pretty streamlined across the state of Illinois. They're typically issued 12 to 48 hour time frame. However, in rare cases, they can be issued beyond 48 hours if confidence is very high. Although, as you'll see, not a lot of times confidence is very high in these type of events. This is specifically quoting the winter weather product specifications paid by the Illinois or the National Weather Service Central Region. Care should be taken to balance the need to inform the public of impending hazardous weather with the need to avoid the effectiveness of watches by issuing too many false alarms. That's exactly what Steve was talking about when it comes to, talking about the Department of Transportation, giving them ample warning to actually do their job, as opposed to, balancing that possibility of a false alarm is such a fine line to walk, and it's very difficult at times. And basically, winter storm watches are issued when there's a risk of hazardous weather is either increased, but its occurrence, location, and timing is still uncertain. So basically, put out broad watches before you kind of start narrowing down where you're going to be seeing the heaviest snowfall. And then we're moving to winter storm warning. So to further complicate the snow forecast and to further confuse the public, winter storm warnings have different criteria in 3 different states, or different areas in the state of Illinois. So the northern portion of Illinois, that's your blue shaded area of Illinois, a winter storm warning means 6 inches of snow in 12 hours, or 8 inches of snow in 24 hours. Now, if you're in the St. Louis area, or basically west central Illinois, in that area, that's the red shaded area, 6 inches of snow in a total event will warrant a winter storm warning. And then if you're in the southern Illinois, the green shaded portion of Illinois, 4 inches of snow in 12 hours or 6 inches of snow in 24 hours will warrant a winter storm warning. And again, these are issued when the winter storm is either occurring, imminent, or very likely, and travel becomes very difficult and impossible in these situations when you have the combination of blowing snow, falling snow, accumulating snow, and basically when you're going to have crews that can't clear the roads fast enough. Now, another big question, and I see this word used improperly a lot, is what is a blizzard? Because a blizzard actually has a very specific definition according to the American Meteorological Society. Basically, that's frequent gusts over 35 miles per hour, reducing visibilities below a quarter of a mile, lasting for at least 3 hours. Now, nowhere in that definition is actually new snow required. So if you had just a recent snowfall event, and you had, accumulating snowfall on the ground, and you have these very strong winds blowing the snow around, and if you're reducing visibilities below a quarter of a mile, lasting 3 hours, you can still get a blizzard warning. And so I've seen at times, you have sunny skies, but you're under a blizzard warning because visibilities are so low because of the very strong wind. So that's the technical definition for a blizzard, if you were wondering. Just a few final thoughts. I see a lot of people say when a winter storm watch is issued and then it jumps to a winter weather advisory, a lot of people will consider it a downgrade. I hate when people say that because it's not technically true, because basically the impacts are still going to be severe either case. And if you tell people that it's a downgrade, you're really just going to kind of confuse them further, and they're just going to think like, oh, it's not going to be as bad. I can just do my daily routine, and they're going to get stuck in the weather, and bad things will probably happen if the forecast verifies the way it is. So it's not technically a downgrade. It's more so just a change of the accumulation of snowfall. That's really the only difference. And then for winter weather forecasting, as we've said, will make you a very humble person, because no matter what your forecast is, you will always be wrong to someone. Someone in your forecast area will not get a right forecast. It's just always how it is. And I'll give you one of these examples. He brought up a few of them. This is another one I found. For Sioux Falls, South Dakota. This is across a city, which is not a very large city. On the northern edge of the city, you had 1 inch of snow. At the downtown airport, you had 4 inches of snow. And at the southern edge of the city, you have 12 inches of snow. So just across a single city, you had nearly 12 inches of difference in snowfall. So it's just so finicky, and it makes you want to get better, basically, as you're forecasting. And then just kind of finally looking at this, again, the models can always pump out totally different numbers depending on where you are. Right now I'm in Macomb, McDonough County, which is in west central Illinois. This was less than, basically, we're approaching 24 to 36 hours away from an event. And you have two of our main models showing vastly different numbers, one showing 0 regard to accumulating snowfall, and the other one showing upwards of 6 inches of snowfall. So just even within just such a short term, even the things that we depend on the most are what the models can vary so wildly from time to time. So that's pretty much what I had on that end of things. As exciting as that is, the joys of severe winter weather forecasting are just second to none. It's something I enjoy doing so much. Like I said, it's a very humbling experience.
So Nick and Steve, I've got a question for both of you. I know that technology for the severe weather that we get in the summer, like for tornadoes, severe thunderstorms, has gotten really good at even being able to say, this is where it's going in, it'll be in this city in this minute, or in this city in this hour. What is it about winter weather that the technology just the forecasting technology hasn't caught up to that point yet?
Well, technology has gotten better in regards to that rain, snow, ice line. We have something on radar that can help us pinpoint that. So things have improved. But it's a good question, but it's comparing apples to oranges. When you're tracking an individual storm cell that might be, and even within that cell, you're really tracking circulation of potential tornado that's only 2 square miles. You've really pinpointed a small area, and you can see the trajectory it's going on. And you can say, well, right there's a potential tornado, so let's assume it's moving 40 miles per hour. We can draw a track. Well, with snow, nothing is 2 square miles. It's a large, kind of like a shotgun. Snowstorms are like a shotgun in the sense that they spread pockets of moderate to heavy snow all over the place. Now, you can sometimes pinpoint that banding I was talking about earlier, and that's real easy to pinpoint. But at that point, people aren't paying attention with the urgency that they pay attention to with severe weather. With severe weather, you're pinpointing a spot where there's potential damage heading right for you. There's a lot of urgency. There's a lot of eyeballs glued to the screen because they need to know exactly where it is when it's going to hit. But if you've told them, in this heavy band, it's going to snow maybe 2 inches to 3 inches every hour, and that's going to slowly shift south through the city over the next 4 hours, you kind of give them everything they need to know, and they just sit back and watch it snow. So it's a much larger problem to try and track, and there's not as much urgency involved with it.
I think in addition to just with the weather models the way they are, just basically everything, if you don't exactly know how a weather model works, it's basically just a giant series of equations. That's pretty much everything is. So you have basically the butterfly effect where like one little thing changes and some, like in like Puerto Rico can somehow have like a massive effect somewhere else across the country. So you're talking just such minuscule things can affect things in such a large way. And that's, I think, especially common with like winter weather too, because like the temperature profiles are so important. And if you have just a little change of the temperature profile, that can mean such a big difference. As opposed with severe weather, it's not as much of a thing where 1 or 2 degrees can be as much as 1 or 2 degrees in a winter weather event.
Our computer models are also, you mentioned their equations. They're not complete equations.
Yeah,
so it's
that's true.
like saying 3 + 2 = 5. It's saying 3 plus something is going to be our forecast. I don't know what that something is. Let's just assume 3. And when you assume, you make a you-know-what out of you and me, right? Have you heard that term? So literally our forecast models are equations with assumptions. We don't understand the atmosphere as well as we'd like to, and so we have to make assumptions. And it's amazing that with those assumptions in place, we're still able to forecast the weather most of the time well enough to help people plan around it. Can I jump into, I forgot to mention this, I'm going to screen share again. I do think it's really awesome that here we are talking about winter weather, and this is the severe threat for Wednesday. And we'll zoom in a little bit. That is a slight risk across all of the St. Louis area that stretches all the way up to probably, it looks like Kankakee there. So clearly,
it looks like your neck of the woods.
Yeah, I'm excited.
We're going to be watching. This is one of those deals where there's a lot of rotation in the atmosphere, so to speak. We call it shear, but not a lot of storm fuel. But if there is just enough storm fuel, watch out. Damaging winds and isolated tornadoes, and they'll move through quickly. And this is going to happen Wednesday afternoon. Down here in the enhanced, by the way, from Arkansas, into Mississippi in particular, the southern portion of this, there could be a little more significant tornado outbreak. I don't know if outbreak's the right term, but there's going to be a more significant chance for tornadoes. So that's always fun.
You gotta thank El Nino for that one, I could say.
All right, I don't know that there's anyone else who's got questions. We'll wait to see if anyone chimes in. But Nick and Steve, if people do want to follow up, if they come up with something, what's the best way to get a hold of you if they want to make sure that they understand something or follow up?
You can always tweet at me. I think that's probably the easiest way I can get back to you really quickly. That's at Nick Stewart, WIU. You can also send me an email. That's at stewie2552@gmail.com. Those are 2 ways. If you have anything you want to send my way, you can go ahead and do that. I'll be pretty happy to respond to that.
Since you are now a certified meteorologist.
I'm so excited. Oh.
What is your handle, Nick?
Nick Stewart, WIU.
I gotcha. All right, cool. And congrats. And for anyone who's watching and doesn't quite understand what goes into a meteorology degree, it's about 2.5 years of calculus, a year of chemistry, a year of physics, and then you start your meteorology courses, which all use calculus and physics.
Mm-hmm.
It's a lot of science, and it's not easy. So congratulations.
Thank you.
You can find me at Steve Templeton on Twitter. I'm pretty active. Rachel knows that. Mm-hmm. And I'm also on Facebook at KMOV Steve Templeton. That's our call letters from our TV station here in St. Louis, KMOV. And then stempleton at KMOV.com. I'm pretty accessible, and I pride myself on answering most people too. So unless I'm bogged down with work, I've got a new puppy, I've got a 4-year-old and a 6-year-old, so I do get bogged down. But if I find time, I will get back to you. And I love talking weather, and I love weather questions, and I love people who have weather curiosities and helping to quench those curiosities. And sometimes I even learn something in the process, because I certainly don't know everything. But it's always fun talking weather.
All right. Nick and Steve, thank you very much. We want to thank those of you who joined us. And if you didn't get a chance to catch this live, you can get it on YouTube on the INBO website later. And if you are interested in future webinars in 2016, we encourage you to become a member of the Illinois News Broadcasters Association. It is $35 for a single membership. If you get enough people together in your newsroom, that number goes down to $25. So again, thank you, Steve. Thank you, Nick. And we'll see you again next time.
Thanks.
Thanks, Rachel.
Thank you, guys.
Thank you.